Welcome to myprojectbazaar.com.
Now we are going to discuss about the product, a feature learning and object recognition framework for underwater fish images. Now we are going to discuss about the abstract for the process. Live face recognition is one of the most crucial elements for fish survey application, where the vast amount of data is rapidly acquired. Different from general scenarios, challenges to underwater image recognitions are powered by the poor image qualities or the dataset images, uncontrolled objects, and environmental, and difficult in acquiring the representative samples. So that here we use the dataset images for the process. In addition, most existing feature extraction techniques are hindered from annotations due to the involving human supervisions. Here we have using the efficient feature extraction as well as the segmentation, although the classification to recognize the fish. Towards this end, we propose an underwater fish recognition framework that consists of the fully supervised features learning technique and an error resilient classifier. So that we have already discussed, we are using the efficient classifier to classify the fish image. In this process, we consist of the three major elements. First one is the segmentation, then feature extraction, then as well as the classification. Here we learned based on the fitness, separations, and the discriminative criteria for the classification. Unsupervised clustering approach generates the binary classification. Hence, the process is well efficient for this classifiers. Now we discuss the flow diagram for the process. At first, the input image is taken from the dataset. After taking the input image from the dataset, the pre-processing is carried out. In this pre-processing, we have to remove the noise from the image. So that here we use the noise removal technique by using the Gaussian filter method. After removing the noise from the image, the noise removed image is undergone for the segmentation process. Segmentation is nothing but to extract the fish image from the other backgrounds. Here we use the k-means clustering for the segmentation. After extracting the fish region, that is the segmented region, we use the feature extraction. In the feature extraction, we have using the three major local features, that is the mean, standard deviation, and the variance. At first, the segmented image is undergone for the feature extraction mean. After extracting the mean value from the segmented region, the standard deviation value are also extracted from the segmented region. Then after extracting the standard deviation value, the variance value are also extracted from the segmented region. After extracting the variance, these three values are combined, that is the concatenate, to form the test features. After extracting the test feature from the image, the classification is undergone. In the classification part, we have to give the three input for the classifier. The first one is the train feature, then the second one is the test feature, and the third one is the target. The test feature represents the feature of the input image, then the train feature represents the feature of the dataset images, then the third label is indicated as the type of fishes. Here we use the KNN classification method for the classifier. At last, the classification output will comes as a text format. Then the performance is estimated by using the precision and recall. These are the two parameters to justify whether the process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. Now you can see the main.m file. right click in that file. If you execute the file, just click the option run. Now the initial GUI design was opened. In that you can see the several push buttons in the left side and the several options in the right side, as well as the two axes in between to display the images. Now click the button input image. If you click the button input image, the dataset folder was opened. In the dataset folder you can see the several fish images present in the dataset. Select any one fish image from the dataset and click the option open. When we selected the input image from the dataset, the selected image is shown in the axis 1 with the title input image. Then click the button pre-processing. After clicking the button pre-processing, these two options are enabled. Now I can click the checkbox first, that is the image resize. Now the image is resized into an aspect size. Then we have to click the noise filtering. After applying the noise filtering, the Gaussian filter is applied to remove the noises present in the image, and the filtered image is shown in the axis 2 with the title filtered image. After applying the filter for the image, the segmentation is carried out. Now click the button segmentation. After clicking the button segmentation, the fish image is segmented as an binary, as well as the clusters is formed for the background as well as the foreground. Here in the fish, and the first image represents the binary image that consists of the two values, that is the zeros and ones. That zeros represents the black area and the ones represents the ones area. Now the figure 2 represents the clustering. Here the background will be eliminated and only the fish regions will be shown in the subplot 1. In the subplot 2, the background regions will be shown in the subplot and the other fish regions will be eliminated. Now this is the segmentation result. Here we want the first image as an segmentation result. So here I can give the cluster index 1 and then click the button apply. Now the segmented image is shown in the axis 2. Then we have to extract the feature extraction. So here I click the button feature extraction. After applying the feature extraction, these three buttons are available. The first one is the mean value, then the second one is the standard deviation, then the third one is the variance. First I can extract the mean value from the image. Then I can extract the standard deviation from the image. Then at last we have to took the variance value from the image. These values are collected and then stored in a background. When we collect the mean, standard deviation and variance from the test feature, that is known as the test features. Then we have to click the button classification. Now the classification result will be shown in the classification GUI design. The classification result, the identified fish type is 12. Then we have to click the estimation. After clicking the button estimation, the estimated parameters will be shown in the GUI. The accuracy for the overall process is 98.3. The sensitivity for the overall process is 93.6. Then the specificity for the overall process is 95.5. So by these estimations only we have to justify whether the process is more accurate or not. So here these are the three parameters like accuracy, sensitivity or specificity is shown in the GUI designs. Thank you.
Thanks for watching this video.